Hi everybody. Today I am going to show you how to determine approximately the reactions and moment at the base of the column of this building frame. Here base means A, B, C and D. As well, two lateral loads are acting on this building frame. So to do the analysis, I will use here the cantilever method of analysis. So to do this, I have to follow three assumptions. So let's see what are those assumptions. First assumptions, a hinge is placed at the center of each girder. We can see it here. And these hinges, it is assumed to be a point of zero moment. Second assumptions, a hinge is placed at the center of each column, and here this hinges is also assumed to be a point of zero moment. Third assumptions, the axial stress in a column is proportional to its distance from the centroid of the cross-sectional area of the column at a given flow level. But here all the columns we are considering, it has equal cross-sectional area. So the axial forces in a column, we can say it is proportional to its distance from the centroid of the column areas. Centroid of the column areas. It's very important to understand. Force in a column is proportional. I mean this column, this column, this column, this column, it is proportional. Force in this column, it is proportional to the distance from the centroid of the column area. It means this column how far from here, again this column how far from here. Another important things I want to mention, these three assumptions what I just now described, it reduces this frame to one that is both stable and statically determinate. Now to compute axial forces in the column, say in this story, what we will do, we will first pass an imaginary section through this hinge. And the free body diagram of the portions of the above of this hinge line, I mean this part, we'll take it and we'll see it in the next slides. As I said, this free body diagram we have taken by cutting sections. Sections where we cut it at the hinges of the column. So what you can see here, or only internal shears and axial forces we can see here at the hinges. Shears and axial forces. Important point is there is no internal moments acting on this free body. I mean where it is cut. Now what you can see. As I said at the beginning, the cross-sectional area of the columns are equal. So right now we can determine the location of the centroid of these four columns from this left column. How? By using a relationship, say this one. So once we get the distance, you can see here distance is 7.5. It means this is that line, because 5, 2.5, 7.5. Because this A5, it means this is 5, again A10, this one, A15, this one, divided by 4A, so we got 7.5. Now, as you can see here, lateral loads are acting on the frame to the right. So we can say the axial forces in this column and in this column, which are left to the centroid, because 7.5 we got, so this is the centroid line. So left to the centroid, these two columns, I mean axial forces in these two columns, we can say it is tensile. And right hand side, these two columns, we can say it is compressive. And another important thing, as I said already, the axial forces in the column are assumed to be linearly proportional to their distance from the centroid. So relationship between them we can establish by means of similar triangles. So what you can write? We can write Fy equal to 2.5 by 7.5. This Fy. Again for Gy, we can write 2.5 by 7.5. As well Hy, we can write 7.5 by 7.5. From this centroid we can 7.5 by 7.5. So we get 0.33 EY, 0.33 EY and 1.0 EY. So our target is to find EY. That is important to find, because once we get the value of EY, surely we can find numerical value for Fy, Gy and Hy. So let's do that. So we'll do what? Summing moments about E. Summing moment about E. How to do that? Fy multiplied by 5. Again Gy multiplied by 10. Hy multiplied by 15. Minus of 12 multiplied by 2. This distance actually 2. I have forgotten to write, but in previous diagram it is there, because total is 4. This hinge at the middle of the column, so it will be 2. So here I put 12 multiplied by 2. Now this Fy, Gy, Hy, I said already we got 0.33 Ey. This is also 0.33 Ey and this is 1.0 Ey. Multiplied by, I mean this 15 already it was, so here it is there. So minus 12 into 2. Solving this we find this, and then Ey equal to 1.44 kilonewton. That was our target, to get this, because once we get this, we know now easily we can find, because Ey we got, so Fy, Gy, Hy we can find it. Now we'll just place the value for Ey. So we get Fy 0.48, I mean this one. Then Gy we get 0.48. Then Hy we get this. So now we got all the axial forces. Here I wrote all those axial forces what I got, say 1.44, 0.48, 0.48 and 1.44. Now I am taking segment from here, because I can take this segment to find these sectional reactions components here and here. As well I can take these segments, this segment also. So first I took this because lateral load is working here. Normally we start from this place first where lateral load is working. So I have taken this. Now we need to find this position and this position, this reactions component. So first what I will do, I will put here column axial force 1.44. Already we received here, we got it here. So surely we can write this. Now I can find this positions vertical component by summing vertical forces equal to 0, because k prime y equal to Ey as this equation equilibrium. We can write 1.44. Without doing this also we understand how much value will be, but this is the normal procedure to check it, because this is only 2. If it would be more, we have to follow this, like summing vertical forces equal to 0, then we can get the reactions, vertical reactions. So we got it. Now our target, here there will be a horizontal component, here there will be a horizontal component at these positions. So what to do that? So first let's find this. How I did it? Say here 1.44. If I take moment about this point, as I said, mk prime. K prime means here. We can see it here. K prime here. So what I got, say 1.44 multiplied by this 2.5, because taking moment here, minus of this Ex multiplied by 2. So easily I get 1.8. So horizontal force I got 1.8. So easily I can say, we know this, we know this. So this minus this, it will be here. Also I can show it, summing horizontal force is equal to 0. We get this 10.2 kilonewtons. So we are done with these segments, all the components we got. Now we'll move for these segments. This is segment L. So what I need to see previous segment, this component. That's why I brought it to see what I got actually. So right away I can copy this to put it here. So what is that? 10.2, 1.44. So let's put this value here. 10.2, 1.44. Magnitude same, but value is same, but direction is opposite. So I don't need that now, already I got it. So now our target to find this. So here vertical component already I know here. For this L segment, vertical component here 0.48. So surely I can write it here. 0.48. Now target is to get this horizontal component. So how to get that? Summing moment equal to 0 about these points, because this is L prime, about this. So what I will get, say 0.48 multiplied by 2.5 minus of 1.44 multiplied by 5, and here say I consider force here horizontal, it is Fx, because this is Fy, so it will be Fx. So I can find it, how much it will be, 4.2. Now remaining this and this. This one I understand very clearly because already I have this 1.44, I have this 0.48, opposite directions. So this minus this, it will be here. As well we can do easily with summing vertical forces. So let's first do the horizontal forces. How it is? I got this, so easily I can find it 6. Then summing vertical forces, it will be 1.92, because vertical force means this one and this one we have. So putting these two value, I get this third one, L prime y 1.92. So we are done for L segments. Now let's move for M segments. So this is a M segments. Same procedure, I have to get the reactions component here. So to get this reaction component means this is M, so I need these points reactions component. So I have to bring segment L. So I brought it. So look at this point, what it is, 6 and 1.92. So let's bring this value here. 6, 1.92, I got it. Now I need these vertical components, but I know it is 0.48. This one, 0.48. So we got it. Now we need to get horizontal component at these points. So summing moment about this point means M prime. We get this 0.48 multiplied by 2.5, this gx multiplied by 2, 1.92 multiplied by 5. Easily I got gx equal to 4.2. So it is here. Now let's go for the horizontal component or reactions component here. How to summing horizontal forces. Here we have 6. 4.2. So putting this, we get m prime x equal to 1.8. So I got it. Now this also easily we can write by seeing these and this, but let's write the equation of equilibrium. So here we got m prime y equal to 1.44. So we are done with segment M. Now let's move for segment N. So to get this point reactions component, we have to bring M segments. Let's bring that. So what is the reactions component here? 1.8 and 1.44. So let's bring this here. 1.8 and 1.44. We got it. Now this one, surely it will be this force 1.44. This. Now we need horizontal component at this point. So summing mm, this is mm prime I have written here. And I wrote here actually mm prime. That is why, because I am taking moment about this point and it is m prime. So this is correct. So if I take this moment about, so surely I can get 1.44 into 2.5, this one, because I am taking moment about this, then hx, which one will be here, multiplied by 2. So 1.8. So let's write this. hx equal to 1.8. So 1.8 we got. So easily we can write this equation, or seeing this we can say also very easily, because here a less number of forces are acting, so easily we can write it directly seeing this value, but we are using the procedure of having equation of equilibrium to get a good habits. Now we are at this story now. So at this position we have to take the segment from here, here. But what we will do first, we have to take the similar triangles. Why? To find this, because we need to calculate this value. Already I have written here, but how I got this, I'll show it here. This is say 2.5 by 7.5 from similar triangles, and uy, this is uy, it will be equal to 0.33 uy. Then it will be same in terms of uy, it will be wy. Same procedure what I followed in previous case for this story, it will be same for this story also. Only the force is different here, uy, vy, wy, xy. So we got this. Now summing moment equal to 0 equal to moment about E. E means actually here I am taking actually moment about this. So it is actually, we can say it is minus Vy into 5. Vy into 5. So what it is? Vy into 5, wy into 10, xy into 15, minus 12 into 6. Same procedure I followed, but here I have to write actually about this u, pu, or means u here, because we are taking moment about these positions, these column positions. So here actually it will be, say, I can change this pen. Here I can say it will be, say, u. Cancelling this, I am putting here u, like this. Okay, so this is done. It will be actually mu at these points. So u means this line. So Vy into minus 5 and Wy into 10, xy into 15, minus 12 into 10, minus 18. This is 12 into this distance. It means 6, because 4 and 2, 6, and 18 into 2. So it will be, say, equal to 0. Now we know this 0.33 uy. So we'll write this 0.33 uy 5, 0.33 uy 10, 1 uy multiplied 15, minus of these two we have to multiply, add it, 108. So we got uy equal to 6.48. So once we get this uy, I mean this one, so easily we can find these three because we have the relations. So we can use this Vy equal to 2.16, Gy equal to this, and Hy equal to 1 into 6.48. So 6.48, we got it, right? That's what I have written here before showing this. This is the value actually. Here, as I told, already we got the forces, axial forces. Now our target to find the reactions component. At this point already we know one part, other we need to find ux, we need to find, and this component we need to find both components here, p prime, q prime, r prime. So let's take this. Already I have taken this. So now looking at this, we can see that we need to put the value, I mean reactions component here. So here reactions component are P, it means I have to bring the K segment here. So if I bring K segment, so it is very clear who is component I need. This 1.8 and 1.44. So let's bring that 1.8 and 1.44. So I got it. Now here these vertical, axial, these vertical components we know how much it is, 6.48. Let's write this 6.48. I got it. Now I need to find this horizontal one, horizontal reactions component. So taking moment about this point means P prime, these points. So what I can do, say 6.48 multiplied by 2.5, then minus 1.8 multiplied by 2, 1.44 multiplied by 2.5, because we are taking moment about this point. So easily I got u x equal to 4.5. So here horizontal reactions component is, here it is 4.5. So I got it. Now I need to get this horizontal component. So what is that? Taking horizontal forces equal to 0, I got this P prime x equal to 0, because we have all the horizontal forces. We have to bring all these red arrows here. So we get this. So what it is? 15.3. Now here I have three vertical components. So easily putting the vertical components, summation of vertical force equal to 0, I get it 5.04. So we are done for P segment. Let's move for the Q segments. So what it is? Q segments. Same procedure we have to follow to get the component here. So looking at positions, you can see I need this component to see what will be here. As well I need to see. So what I want to bring P and L segments. So let's bring first P. So once I brought P, so I need this point. It means here 15.3, 5.04. Let's transfer this here. 15.3, 5.04. So it is done. So P segment we already copied. Now we need to bring the L to get these positions, I mean here. So let's bring L. What is here? 4.2, 0.48. Already it is written 4.2, 0.48 according to this. So L segment we already copied. So it is done. Now here this force we know because by looking here we understand this is 2.16. So this is 2.16. Now need to get this horizontal one. So summing the moment equal to 0 about this point. This point means Q prime. So we got 2.16 multiplied 2.5, then 5.04 multiplied by this 5, then minus 4.2, this one multiplied by these 2.48 multiplied by also 2.5. So we get this Vx equal to 10.5. So we got it. Now our target to get here, already we know 3 red arrows means horizontal forces. So bringing those 3 in this summing of horizontal forces equal to 0, we get Q prime X equal to 9. So it is done. Now vertical forces, we have 1, 2, 3, 4 vertical forces. We have to bring here and see how much it is, 6.72. So we are done for Q. Now we brought this segment R. So here what are the forces? Let's bring Q. So this force will be 9 and 6.72. Let's put this here. 9 and 6.72. Done. Now we need to get force here. So remove this Q and bring M. M means I need this force. What is that? 4.2, 0.48. That's what I have written. 4.2, 0.48, but opposite direction. So we are done with this. So let's remove that. So we are here now and we got this force. Is very easy to get because R down, if you look at this arrow, it is showing force is axial force is 2.16. So it is kept. Now we need to get horizontal. Horizontal means we have to take the moment about this point and taking moments and including all this force 2.16, 2.5, 6.72 multiplied by 5, 4.2 by 2 and 0.48 multiplied by 2.5. So we got 10.5 Wx. So this is the horizontal component of this point. So we got it. Now here easily we can find horizontal component bringing the 3 red arrows values. So we got it. We found R prime X 2.7. What about this? Summing vertical force is equal to 0. So we get this R prime Y equal to 5.04. So we are done for this segment also. It is calculated. Now let's move for S. What is that? We need to get the reactions components here. So we need to bring R. We bring R and we know what is the force component here, 2.7, 5.04. So let's bring here 2.7 and here it is 5.04. So we got it. Now we need to get value for these positions, I mean this component at this reactions component from N. So let's bring N segments. So N segments we got here 1.8, 1.44. So these two value will be here. So 1.8 and 1.44. Got it. Now I need to get this force. I know this force how much? This is this one, 6.48. 6.48. Got it. 6.48 I got. What does it mean? I got this. So I need here horizontal component. It's very easy to get. Summing these two, we get this. This and this, summing these two. But I am writing in equation form like this. Or you can get it for checking. You can get it taking moment about these points. You will get 4.5. As well, summing horizontal force is equal to 0 also you will get the 4.5. Even without this also you can say how much it will be. By seeing you can say what is the forces will be here. Because this is only two forces in one direction. So opposite direction will be summing these two forces. That's what it is done here. By moment also it will be the same value. So we are done here. So let's move for taking these values, I mean 6.48, 2.16, 2.16, 6.48 towards the supports. As I told, 6.48, 2.16, 2.16, 6.48. So this same values will be here for the reactions, vertical reactions. Now let's see the horizontal forces here, I mean shear forces here. This direction we get this. Now for these supports it will be same value but opposite directions. Now as I know this force 4.5 multiplied by 2 I get 9 moment. 10.5 multiplied by 2 it will be 21 kilonewton meter moment at this support. Again 10.5 multiplied by 2, 21 kilonewton meter, and 4.5 multiplied by these two it will be 9 kilonewton meter. So we already got the moments as well as the support reactions we got, vertical and horizontal forces we got at these supports, I mean all reactions and moments. So I think that's all for this building frame. So we are done.